In this video, we will continue learning how to name compounds. Okay. So now let's focus on naming the molecular compounds. So remember, these include compounds that contain nonmetals. Okay. So molecular compounds will have nonmetals and nonmetals. So again, focusing over here in the upper right-hand corner are the nonmetals, including hydrogens. And again, we're also going to focus on binary molecular compounds, meaning we're only going to concern ourselves with two elements for binary, so two nonmetal elements. And when we name these, you're going to name each element. The first one is named as listed first, and that one will have a prefix to tell us how many it has. And we're going to use the numerical prefixes that you might have learned at one point, right? So mono for one, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. So this tells us how many of each element we have. And then the second element that's listed will end in "ide." So we would add IDE to the root name of the second element. And one other note is that if the first element listed has 1, we don't use mono. We only use that for the second element. All right, so for example, let's write these a little larger, right? CO. So we have carbon and oxygen, and we know that these are both nonmetals, right, found up over here. We're not going to use mono for carbon, and so we will just write carbon, the first element, but we will use it for the second element, and that one is oxygen, which will end in "ide," so carbon monoxide. Okay. And the reason we have to use these numerical prefixes is because we have multiple compounds that contain the same two elements. So we can't just say we have carbon oxide because we wouldn't know which carbon oxide we have. We could have carbon monoxide or we can have carbon dioxide. So again, write the name of the first element. There's only one, so we don't add the mono. We see the second element has 2, so we use the numerical prefix di, oxide, end it in IDE. All right, so because molecular compounds do not consist of ions, right, that the nonmetals that compose them are in ratios that are difficult to predict. So like I mentioned, you can have many different molecules that contain the same two elements. Okay, so we already went over carbon monoxide and carbon dioxide. Now let's just name a few of these. This would be sulfur dioxide. Right? We can also have a sulfur trioxide. Okay, so we can't just say sulfur oxide. Let me fix that. That looks terrible. Sulfur trioxide. Okay, and then look at all these compounds we have for nitrogen and oxygen. Okay, so we have nitrogen monoxide, nitrogen dioxide, nitrogen trioxide. Let me write a few of these out now. Okay, so now we have the first element has more than one. So we do need to use the prefix. So this one is dinitrogen monoxide. And we have to use the mono for the second element, listed in IDE. Okay, let's write this one. So we have di-nitrogen. And now we have 4, that's tetra. And sometimes, so that there's an A there, you usually drop the A if you're going to be right next to another vowel. So we'll write tetroxide because you don't want the A and then the O. Okay. Same with this next one over here. This one is dinitrogen. And again, it's penta, but we'll just drop that A and do pentoxide. Okay, so again, here's a review of your prefixes. Right? Again, note that the mono prefix is not used for the first element, and it is also not used for the second element when there are no other compounds with the same combination of elements. Okay, this might be hard for you guys to know at this time, but some of them that you will come across when they're not acids would be like this symbol here means gas. So that's hydrogen fluoride, right, as a gas. And because there's no other compounds between hydrogen and fluoride, we don't need to say hydrogen monofluoride. So you would just say hydrogen fluoride. Okay. So this happens with the halogen. So HCl, HI, right, HBr. You don't need to use mono in front of the second element. Okay. So let's do a few of these. Try naming these compounds using the rules. Okay. So we have these are all nonmetals. So sulfur dioxide, nitrogen, tri for 3, fluoride. And that's 4, so tetra, phosphorus, decoxide for 10. Okay. Okay, so now moving on to the acids. So this is when you have the hydrogen plus an anion and the charges balance out. So when the H cations balance the charge of the anion, meaning they're no longer an ion, right? Another way you would know if it's an acid, you will usually see the symbol, mess that up, AQ for aqueous, meaning it's dissolved in water. So let's just review real quick what an acid and a base is. And this is just it's very simplified here. So an acid, right, is a substance that when you dissolve it in water will produce H plus ions. So like HCl, you put that, it's originally a gas, hydrogen chloride, but you bubble it through water and it will dissociate into H plus ions and chloride ions. And if you produce H plus, right, this means it's acidic. Bases are substances that will produce hydroxide ions. So this is one of your polyatomic ions. So sodium hydroxide is a base. When it's dissolved in water, you'll get sodium, but it's the hydroxide that makes something a base. And if you notice, if you add a H plus a hydroxide, what do you make? You make HOH, which is H2O, which is water. This is why acids and bases neutralize each other. Now, we're not too concerned about naming bases because bases that we'll be dealing with are just hydroxides, which is a polyatomic ion. So you would just name it like lithium hydroxide, barium hydroxide. You just name it as you would any other ionic compound. But acids, right, they have a naming system. Okay, so if your anion ends in "ide," we're going to add "I-hydro" to before the root of the anion name, followed by "ic acid." All right, so let's talk about what I mean. So let's use these examples below. So this is HCl. You will see the aqueous there, meaning it's acidic. We know this is made up of H plus, and this is Cl minus. The Cl minus is monatomic. So when we name this acid, we're going to add hydro and then have ic acid. So it will become hydro, and then chlor is the root name, ic acid. Okay, so let's just underline it. Hydroic acid. Okay. Now, if your anion ends in "ate," right, ATE, it's polyatomic, you will just add ic acid to the end of the root name. So if we had like H, let's use the chlorate. Okay. So we know this comes from H plus, and this comes from ClO3 minus, which is chlorate. Right? It ends in "ate." So all I'm going to do is replace that with ic acid. So that becomes chloric acid. Okay, so let's underline that. Just the ic acid because it ends in "ate." Okay. And I guess I should probably do the same up here. So this one was chloride. It ended in "ide." So that's why we used hydrochloric acid. And if it ends in "ate," it's just chloric acid. Now, if it ends in "ite," so let's use this one. We have H plus and we have ClO2 minus, which is chlorite. Okay, so if it ends in "ite," right, you will end it with "us" acid. And this is "ite." So it becomes chlor-us acid. Okay, so the ending here is "us" acid. All right. Okay, so what is the name of the following acid? Okay, so we would take it apart and we would see that we have the two H pluses, and we have this polyatomic ion. Okay, so you have to know the name of the polyatomic ion. and this is oxalate. And we recognize that ending, right, as 8. So what would be the name of the acid? Right, you would just add ic acid, oxalic acid, which is A. All right, let's take this time right now to just do a couple examples. It's all mixed up now. Okay, so we have ionic, molecular, and acids here. Okay, so here we have a metal, aluminum, non-metal, sulfur. Aluminum has a fixed charge. Aluminum sulfide, that's a monatomic, right, anion. All right, so the next one, number 2, you have an acid, and we see that it's between H plus and NO2 minus. You have to know the name of that one, right, which is nitrite. It ends in ite, so it would become nitrous, whoa, my pen, nitrous acid, okay, because it ends in ITE. Okay, here's another acid, that's H plus and iodide. Iodide, it ends in IDE, so this one would be hydroiodic acid. A hydroic acid, hydroiodic acid. Okay, next one, we have a metal, we have a polyatomic ion. That is copper. That is a transition element, so it is going to need a Roman numeral, copper 2 hydroxide. How did I know that was a 2? Well, if I break it down, I have 1 copper, I have 2 hydroxides. You have to know that they're -1. That's a -2 balanced by a +2. That's 2 plus. That's the Roman numeral. Okay, here's another acid coming from sulfite. So this one is sulfurous acid. We kind of add a little bit to that name. So it's not sulfurous acid, it's sulfurous acid. We have carbon and sulfur, that's 2 nonmetals. So that one would be named carbon disulfide. So we're naming it as a molecular compound. Okay, next one, we have ammonium and carbonate. So that's a cation and an anion. So it's ionic. 2 polyatomic ions, just write their names. Ammonium carbonate. And then the last one, we have iron and acetate. That's a metal, right, with the non-metal anion. That metal is a transition metal. So that's iron. There's 3 acetates, so that makes this an iron 3 plus acetate. Okay, you have to know that the acetate ion is a -1. Okay, so it takes practice, lots and lots of practice.